So ABC is a Poncelet triangle between conics E and the caustic E prime. K is some generic circle centered on a generic center O. A prime, B prime, C prime are inversive images of A, B, C with respect to K. Okay, so you start from this triangle A, B, C, and you invert the position of its vertices with respect to K, and then you get triangle A prime, B prime, C prime. So you go from blue to green. Now, what is interesting about this the setup, I'm also displaying here that over Poncelet, first known result, is that the circumcenter x3 of ABC will trace a conic. Okay, so this is a known result. I'm now sort of jogging through the Poncelet family, and you can see x3 blue sweeping a conic. Now this is always guaranteed for any generic Poncelet. What this video is showing is that, surprisingly, the circumcenter x prime 3 or x3 prime of A prime, B prime, C prime also traces a conic. Okay, now first of all, let's look at the components of this diagram. You can see here that this inversive triangle is inscribed in what is the inversive image of this outer ellipse with respect to K. Okay, so this is probably a degree 4 curve because inversion typically doubles the degree. So I'm going from a conic, the black E, external Poncelet conic, to this thing here. And then A prime, B prime, C prime over Poncelet, as you can see, will write on that. Okay? You can see that it's writing on that. Now, what this video is showing is a couple of phenomena. First of all, the instantaneous circumcenter x3 prime of A prime, B prime, C prime, and let me put this in a easier to see position, seems to be collinear with the center of inversion. So x3 prime and the center of inversion, these 3 points, seem to be collinear. And this seems to be a more fundamental property of the circumcenters of a reference triangle ABC and this inversive image of ABC, which becomes A prime, B prime, C prime. And the lemma that needs to be proved here is that x3 and x3 prime are collinear with O. But what's really interesting as well is that out of all the triangle centers of A prime, B prime, and C prime, I've found that only x3 prime is guaranteed to sweep a conic. And you can see here that the conic is this green thing here. And that the conic it sweeps is actually not homothetic to the conic that is swept by x3 of ABC, and neither of these is homothetic to either E or E prime. So let's watch the phenomenon. Animate this thing. There you go. So you can see here that as we sweep Poncelet, x3 and x3 prime are always collinear with the center of inversion. Okay? And that x3 prime surprisingly sweeps a degree 2 curve, a conic. Okay, if you try to do this with x1 in center, x2 the barycenter, x4 the orthocenter, and I've tested from k equals 1 to all the way to k equals 100, going through Kimberling's list of triangle centers, none of them are going to sweep conics except for x3. Okay, so that's the result. See you on the next video.